Hello everyone, my name is Abhishek and welcome back to my channel. Today is episode 5 of DevSecOps Zero to Hero series, and in this episode, let's focus on securing Kubernetes. In the previous episodes, we learned how to secure Git, how to secure Terraform, how to secure your containers. In the same way, we will learn what are the security best practices when it comes to Kubernetes in today's video. We will cover 6 different topics in the video, starting with what are namespaces and why are they called the first step of security. Then we will learn about RBAC in Kubernetes, where we will learn what is RBAC, what are different components that can help you with RBAC. Then we will learn about network policies in Kubernetes. For example, how can you restrict access to your database that is deployed in your Kubernetes cluster? Then we will learn about advanced policy enforcement. For example, how do you set up and manage your Kubernetes cluster as per the compliance of your organization or as per security requirements? Here we will learn Kyverno. Yes, I will also explain you how to set up and configure Kyverno in today's video. Then we will learn about secrets in Kubernetes. How do you store sensitive information within your Kubernetes cluster? And finally, we will learn how to store your Kubernetes secret references within version control systems like Git, where we will cover a very important concept, external secrets operator. And I'll also explain you how can you integrate external secrets operator with vault provider. So these are the concepts that we are going to learn in today's video. Most importantly, this video is going to be completely practical. So every concept that we are going to learn today will be followed by a demo. And you don't have to feel overwhelmed. All the documentation is covered as part of the Git repository. So this is a GitHub repository that we are using for the series, DevSecOps Zero to Hero. You can find the link in the description as well. If you head to the Day-5 folder, you will find a README file. And this README file has everything that I'm going to cover. You can see here, the first section is namespaces, the commands related to namespaces. Then the second section is RBAC, commands, configuration, verification, everything related to RBAC. Similarly, network policies, Kyverno, and even external secrets operator. So after watching the video, I would request you to spend another 30 minutes and practice everything that is covered in the documentation. That way, you can never forget security in Kubernetes. Perfect. So now without wasting any time, let's get started with the first concept for today's video. That is namespaces. So what is a namespace? As I told you, it's a very simple concept, yet very, very powerful. Namespaces in Kubernetes offers the isolation that helps you manage a single Kubernetes cluster across different teams in your company. Let's try to understand this better through a real-time example. Imagine you created a Kubernetes cluster within dev environment of your company. And let's say you have 3 different teams in your company: payments team, shipment team, and scores team. As soon as you create this Kubernetes cluster, let's say you posted on Slack that you created a Kubernetes cluster, and these are the cluster details. The DevOps engineers who are managing the deployments of these teams, they start deploying their containers to the cluster. Now, if you imagine the world without namespaces, the DevOps engineer of the payments team can just deploy their one of the container as pod, other container as another pod, and maybe a config map. Similarly, to the same cluster, The shipments team DevOps engineer deploys, let's say, 2 pods. And the scores team DevOps engineer deploys 2 pods and 2 config maps. Now this looks good to you, but what if after some time the DevOps engineer of the payments team accidentally deletes a pod and a config map of the scores team? Now this is a big issue because there is lack of ownership on the cluster. Similarly, the scores team DevOps engineer can accidentally delete the pod of the shipments team. This is not only a security issue, but this is also lack of ownership on the cluster. On top of that, you will also start receiving the complaints. For example, the scores team can complain, Abhishek, we have 2 pods and 2 config maps, but the shipments team and the payments team are utilizing 90% of the cluster resources. Now, this is another problem, that is resource utilization. Ideally, you might want each team to utilize 33% of the cluster, or maybe because scores team has 2 pods and 2 config maps, and maybe these pods are very important for your company, you might want them to utilize 40% and other teams to utilize 30% each. How do you define this? That is, how do you define resource utilization on the cluster? Now you can only do these things if you logically break your Kubernetes cluster. One thing is sure, you cannot physically break a Kubernetes cluster because this is not a physical thing. Only thing that you can do, you can logically break the cluster. And this logical isolation is what we call as namespaces in Kubernetes. So when you have 3 teams in your company, you might create 3 namespaces and you might assign 1 namespace for a team. So this namespace is for the payments team, this namespace is for the shipment team, and this namespace is for the scores team. Now the DevOps engineers who are working with deployments, they start deploying their workloads. It can be pods, it can be config maps, it can be secrets or anything. They would deploy their workloads to the relevant namespace. Very simple. Previously, they just run kubectl apply. They would use the same command, but this time kubectl apply followed by -n followed by namespace that is assigned to that team. But Abhishek, okay, this is fine. Now the payments team DevOps engineer would use -n payments. Shipment teams DevOps engineer would use -n shipment. But how to solve the problem with resource utilization? That still exists. You logically break the cluster, but how do you define a particular team or a particular namespace should only utilize, let's say, 30% of the cluster resources? It's actually very simple. So Kubernetes solved this problem using resource quota. So when a DevOps engineer creates the Kubernetes cluster or an administrator creates the Kubernetes cluster, and when they define a namespace, while creating the namespace, they also create resource quota for the namespace. It's just a Kubernetes resource. And within the resource quota, they define the number of CPUs and the amount of memory that a particular namespace can use. So if this Kubernetes cluster has, let's say, 30 CPUs and 30 GB RAM altogether, while creating the namespace called payments, they can also define the resource quota and say this namespace should utilize 10 CPUs and 10 GB memory. No matter how many workloads they deploy, it would not exceed 10 CPU and 10 GB RAM. This way, resource quota helps the DevOps engineers or the administrators to maintain dedicated amount of resources for the namespace. Perfect. Now let's see the namespace in action. How do you create a namespace and how namespaces are used in real time? For that, we would need a Kubernetes cluster. My go-to thing is always kind. So I just installed Docker on this machine. Now I'll just run kind create cluster hyphen name followed by, let's call the name of the cluster as keds demo. So you would need Docker running on the machine and you would need kind running on the machine. It just takes 2 steps to install Docker and kind. There you go. So we have a Kubernetes cluster. It's that easy. Now, once we have the Kubernetes cluster, how do we logically isolate it? How do we create namespaces? So we need this command kubectl create ns, which is the shorthand for namespace, followed by name of the namespace. If you want to call the namespace as payments namespace, you can just say payments ns. Namespace is created. You want to create another namespace, just call it as score namespace. Now if you run kubectl get ns, you will find along with the default namespaces, there is a payments namespace and there is a scores namespace. Now let's understand how workloads are deployed to the relevant namespace. For example, DevOps engineer of the payments namespace wants to deploy Nginx within the payments namespace. So they can just use the command kubectl create deployment, or they can prepare a YAML manifest as well. But because this is just an Nginx deployment, I'll show you through the command line. They can just run kubectl create deployment. Name of the deployment, it can be Nginx, it can be Nginx payments, followed by the name of the image, which is important. It has to be right, followed by -n payments. Now you will see here, okay, there should be some typo in the namespace that we created, kubectl get ns. Okay, it's payments namespace. So I have to just change it to payments-ns. Now you will see, if I run kubectl get pods, there are no pods here. But if I just do kubectl get pods -n payments ns, you will see the Nginx pod running in it. The same way, if the scores DevOps engineer wants to deploy the same Nginx pod within their namespace, they will run the same command, but change the namespace to score-ns. So this is how namespaces are used in real time. But you might have a question here, Abhishek, okay, we logically broke the Kubernetes cluster into multiple parts. But what if, I have a requirement where I want to grant permissions to my pod. I don't want my pod within the payments namespace to do every action that is possible. In Kubernetes, there are multiple actions like creating a config map, reading a config map, reading a secret, writing secret, reading custom resource definition, a number of actions. But I want to restrict my pod only to read the config map. That's it. Nothing more than that. If my pod tries to write a config map to the local disk or maybe to the node of the cluster, this action should fail. How do I do that? Basically, how do I grant permissions to my Kubernetes pod? This is where our second concept comes into picture. That is RBAC. What is RBAC? RBAC stands for role-based access control. The term RBAC is not limited to Kubernetes. It's basically a security term where it is applied to different tools and different concepts. But in Kubernetes, RBAC is applied using 3 resources. If you know these 3 resources and how to use them, you can master RBAC concept in Kubernetes. What are these 3 resources? First one is service account. Shorthand is SA. Second one is role. Third one is role binding. That's it. You just need to understand what are these resources. Let me explain you one by one. First thing is service account. Service account is just like the user account. What is a user account? For example, if I want to log into my laptop, I need a user account. If I want to perform any action within my laptop, I have to log in using a user account. It can be administrator, it can be Abhishek, it can be Veeramalla. Only then I'll be able to do something if I have permissions. But the first thing that I need is a user account. In the same way, in Kubernetes, every pod should run with a service account, right? A pod in Kubernetes cannot run without a service account. But Abhishek, in the previous example, I created a pod, right, using kubectl create deployment. When I do kubectl get pods -in payments namespace, I can see a pod is running. I did not define service account. Very simple. If you try to edit this pod and see kubectl edit pod, name of the pod, right, and -n payments namespace, you will notice, although you did not provide a service account, Kubernetes assigns default service account. This line here, you can see if you don't assign a pod with a service account, Kubernetes automatically defines the default service account. But this is not a good practice. And this is not what you should do in real time. Every time you create a pod, you should assign the pod with a service account and it should only run with it. But service account is just an account. By default, it will not have any permissions. Just like I can create a user account on my laptop and I can share it with my wife or I can share it with my friends. But if I don't give any permissions to them, they can log into my laptop, but they cannot do anything. The same is with service account. Now, what grants service account some permissions? Basically, that is roles in Kubernetes. What are roles? As the name suggests, role is nothing but you define what a service account or user account can do. So Kubernetes administrators separately, they create some roles. A role can be developer or role can be test user, right? Or a role can be test pod or maybe test pod payments, whatever you would like to define. The name of the role is anything, but here you will define the permissions. Read, write, config map, read, write, secrets, read, write, CRDs. So you will define whatever permissions that is required. But Abhishek, how do we bind a role with a service account? Okay, I created different roles. I'm an administrator. I created a role called developer. I created a role called test user. I created a role called test pod service account. How do I bind the role to the service account? That is where role binding comes into picture. All that role binding does, it will bind a role to a service account. That means administrators create service accounts, administrators create roles, and they bind a service account to a role using role binding, right? Role binding does not have any other use case in specific. It will only map a role to a service account. Now let's see this thing in action as well. If you are confused, when we perform the demonstration, things will be much easier for you. So we will go back to our same Kubernetes cluster and let's create a service account first. So how do we do that? We can run this command kubectl create service account followed by name of the service account. Let's call payments user. Okay. And hyphen n payments namespace. Perfect. Payments hyphen ns. Perfect. So payment service account is created. Now let's create a role and let's grant permissions to get and list other pods. That's it. Okay. How do you do that? We will run this command kubectl apply hyphen f and we will use this manifest. Kind is role, metadata, name of the role, namespace. In our case, it has to be payments hyphen ns, right? Followed by the rules that we want to grant this role. So the verbs decide what permissions will this role have on what resources. So the permissions that we are granting, get and list on the pods. Now, whichever user account or service account is assigned with this role, they will be able to get, that is, they will be able to run kubectl get. They will be able to run kubectl to list out all the pods within the cluster. If I change these pods to config map, they will be able to run kubectl get config maps and they will be able to list all the config maps only within the payments namespace. Again, if they try to run kubectl get on a different namespace, even for the pods, their execution will be failed because this role here is only restricted to the payments namespace. Let's create this as well. Okay, we created service account separately. We created role separately. Now we have to bind this service account to the role. How do you do that? We will run this command kubectl apply hyphen f followed by the file that has role binding configuration. The role binding configuration, as you must have guessed, it has the name of the service account and it has the name of the role. What is the name of the role? Pod reader, the one that we defined. Let me just correct the namespaces here. The namespace here should be payments hyphen ns. Similarly, payments hyphen ns. That's it. We are good enough now. Let's do this. Okay. So now service account is created, role is created, role binding is also created. Let's verify if the service account called payments user can get the pods within the payments hyphen ns namespace, which should be successful because we granted the access. This is the command to verify the permissions. kubectl auth. Can I list pods as payments user service account in the payments hyphen ns namespace? What should be the output? It should be yes. There you go. Now, if I try to see, okay, instead of list, if I change this to kubectl auth, can I create pods? The output should be no. Similarly, if I run kubectl auth, can I delete pods? Again, the output should be no. Even if I do kubectl, can I get pods within the payments namespace? You would see yes. But if I change the namespace, okay, from payments namespace, if I just do something like score namespace, you would see the output again as no. Why? We created the role, but the role is restricted only to the payments namespace. Using this payments user, if you try to perform actions in a different namespace, your execution will fail. But Abhishek, what if I want to, grant my pod? In this case, if I want to grant payments user to read pods across all the namespaces in the cluster, should I create multiple roles for it? It will take a lot of time. You don't have to do it. Kubernetes also supports something called cluster role. So in that case, you can create a cluster role and cluster role binding. Basically, role and cluster role are almost the same, but role is limited to a namespace. Whatever permissions that you want to give in the role, they will be limited to a particular namespace. If you want to grant permissions across the cluster, across all the namespaces in the cluster, you would go with the cluster role. That's the only difference. Perfect. So this is how RBAC works in Kubernetes. And you should definitely implement RBAC. This is one of the most important things that you have to do. Whenever you create a Kubernetes cluster, create namespaces and create RBAC for the service accounts that you use. Without this, your Kubernetes cluster will be a security mess. Anyone will be able to delete other pods. Anyone will be able to create config maps, read secrets, which is a security issue for your organization. Okay, now that you learned about namespaces and RBAC, let's go a step ahead. Let's learn about a very interesting concept, that is network policies. I'll explain this to you in very simple words. Imagine you created a Kubernetes cluster. Whenever you create a cluster, the Kubernetes cluster is set up with internal cluster network. That is, all the pods in the Kubernetes cluster can by default talk to each other. This pod can be in the payments namespace. This pod can be in the scores namespace. Because they share the internal cluster network, they can talk to each other using curl, or maybe the payments pod can make an API request to the pod in the scores namespace. Let me show you as well. Now, if I just do kubectl get pods -a, that is pods in all the namespaces, followed by -o wide, you will notice this is the pod in the payments namespace. This is the pod in the scores namespace. They share the same CIDR block. This is 10.244.0.6, 10.244.0.7. They are in the same network. So now this payments namespace pod can ping the scores pod, or maybe make an API request to it, which is a huge security issue. Maybe not for every company, but for certain companies, it is. Why? Let's take the classic example. There is a front-end pod in the login namespace. There is a backend pod in the, let's say, score namespace, and a database in the DB namespace. Now, backend talking to the database, it's absolutely fine. It's a very common scenario. But front-end talking to the database should definitely be blocked. Otherwise, any potential hacker or a bad actor who has access to the front end can penetrate and access to the database. Or if your front end pod is compromised for any reason, through the front end pod, the hacker can penetrate and access the DB pod. Maybe make a curl request to it or gain access to the database and steal information from the database. How do you prevent this? As I told you, front end and DB or any other pod, they share the same cluster network. What you need in this case, ideally something like firewall, right? Something that protects your DB pod. But firewall becomes complicated. What Kubernetes does, Kubernetes supports even a better solution called network policies. How does network policies work? So you can define access to your pods. In this case, you can define access to your DB, that is, who can ingress to your DB. Which pods should only have access to your DB. You can even control egress access. If you try to make request from your DB pod, the request should be blocked. Or if someone tries to make request from the front end pod, anything, someone got access to the front end pod, they try to run a curl command, they try to run the ping command, you can block egress access or outgoing network access from the front end pod. You can do all of this using Kubernetes network policies. Of course, I made a very detailed video on the network policies, but still, because we are talking about security, I will show you this through a very useful demonstration. So what we will learn, how to set up network policies. Unfortunately, when you are using kind cluster, by default, kind is not capable of network policies. So we will install Calico in the cluster. Calico is basically a Kubernetes network interface that helps us set up network policies. And then we will take the scenario of almost the same thing, a front-end pod, attacker pod, and back-end pod. So our goal is very simple. Attacker pod should not be able to make even ping request to the backend pod. But if front end tries to connect to the backend through a ping or something, this request should go through. Let's try to see this. One more time. We will create 3 different pods: front end, attacker pod, and the backend pod. Front end pod should be able to make request to the backend pod, but if we try to even make a ping request from attacker pod, it should be blocked, although they are in the same network. Firstly, I'll show you without network policy, right? So we will install a Kubernetes cluster that we already have. We will set up Calico in the cluster as the next step. We will deploy 3 pods. I'll show you first without network policy that attacker pod can talk to backend pod. Then I'll install the network policy to show you how to block the access. Perfect. We already have the Kubernetes cluster. I will create something called the payments namespace, kubectl create ns payments. The documentation has commands related to the payments namespace. That's why instead of modifying every time to payments-ns, I just created the payments namespace. It will be also easy for you. You can run the same commands from the docs. First, let's create the front end pod. We will use this command here, kubectl run frontend -- image busybox. So I have taken a very simple busybox image. We are running the front end pod. I attached labels to the front end pod. Role front end. Abhishek, why are you attaching labels? Because when it comes to the network policies, you block the access only using labels or annotations. I will use labels here to block the access in the future. That's why when I'm creating the pod, I'm creating the pod along with the label. So front end pod has the label called role front end. Okay, so this should create front end pod for us. Now let's create attacker pod. So this is the attacker pod, kubectl run attacker -- image busybox -n payments. If you notice here, I did not add any label to the attacker pod. It's just like any other usual pod. Then I will also create the backend pod. Kubectl run backend -- image nginx, and I have added label to the backend pod as well. Very simple. I added label to the front end pod and backend pod. I did not add any label to the attacker pod because network policies work with the labels. Now let's expose the backend pod. That is, I'll just create a service for the backend pod so that we can easily make curl request to the service. Perfect. So we created a service for the backend pod as well. Now we will just verify all the pods are created and running. Kubectl get pods -n payments. There you go. All the pods are running. kubectl get svc -n payments. So you can see the backend service. The reason for creating service, if I use the cluster IP, using the pods, a pod can go down for some reason. During the demo, if the pod goes down, our curl request might fail. That's why to use a stable IP address or maybe to use a stable DNS, I created service. Otherwise, we can also use the backend pod IP. There is absolutely no problem. Step 1, I'll connect to the attacker pod kubectl exec -it attacker pod -n payments. I'm taking shell to it. Now, firstly, I'll show you we did not create anything in the sense we did not create any network policies. I'll just run this command wget -qo backend svc. From attacker pod, I'm trying to connect to the backend pod. Let's see what happens. Request went through. Welcome to Nginx. That means attacker got access to the backend pod. Of course, even front-end pod will be able to connect to the backend pod. Now let's see network policies in action. So firstly, I will install Calico on this cluster. So this is a command to install Calico. It's also in our documentation. If you are using EKS cluster on AWS, you would not need Calico even because your EKS cluster will be set up with the VPC CNI, and VPC CNI already has support for the network policies. If you're only using kind local Kubernetes cluster, you would need this step. Okay, all the CIDs are installed. The Calico CNI is set up. Now I'll install network policy. So I'll run this command kubectl apply -f followed by the network policy manifest. Let me walk you through the manifest. So what are we doing here in the network policy? So we are saying allow only specific traffic. This is just the name of the network policy. You can grant anything. Here we are defining the pod selector. What is the pod selector? I am saying this network policy should only be applied to the pod which has the label app my app. If you remember, we use this label on the backend pod. I can quickly show you as well. kubectl get pods -n payments. So this will list all the pods for us. If I just run kubectl edit pod backend -n payments, you will notice backend pod only has this label called app my app. So that means the network policy that we are creating will be associated with the backend pod. Okay, so we defined which pod should the network policy be associated with. Then policy type. Which policy type? Ingress is the policy type. That is, inward traffic to the backend pod should only be allowed from the front-end pod. The pod that is assigned with the role front-end. Any other pod which tries to access the backend pod, ingress should be blocked. That is, the incoming traffic should be blocked. Let's see if this works out. There you go. Network policy is created. We'll replicate the same steps. I'll again exec to the backend pod using the same command kubectl exec, the attacker pod, kubectl exec -it attacker pod. Now let's run the same command. You will notice the access is blocked. There is no response back. Even if I try to do ping followed by backend SVC, the ping is also not going through. The ping is also blocked. On the contrary, if I try to run the same command, now I'll switch this to the front-end pod. Okay, -xt front-end. I'll run this command wget. You will see the response. There you go. This is how network policies work in real time, right? So we understood the concept theoretically and practically. If you want to block access to certain pods, or if you want to define egress access from the pod, what you need is network policies. Best use case is database pods or the backend pods. But Abhishek, what if, on top of the usual network policies, I want to define strict policies within our company, right? Our company has very strict policies. For example, anyone who deploys a pod on the Kubernetes cluster, or anyone who deploys deployment on the Kubernetes cluster, should not use the latest tag. I'm sure you know the consequences of using latest tag. Otherwise, let me explain you. Let's say you deploy MySQL pod with the latest tag. Every day, this tag keeps changing, right? So you have deployed MySQL with the latest tag today. This might be working, but tomorrow, the developers of the MySQL, maybe at 12 a.m. in the morning, they might update the latest tag, and now the latest tag is pointing to different version of the application, right? That is what the purpose of the latest tag. Latest is always up to date. Today the MySQL version might be 16. Tomorrow the version is 17. But you are not using the version number as 16 or 17, but what you are using is the latest tag. That means yesterday latest point was pointing to version 16 of your application. Today the latest tag is pointing to version 17 of your application. This is a major problem in production because yesterday your application might work perfectly fine in the production. Today it might break because of the breaking changes in the 17 version. Of course, applications like MySQL, most of the times they are stable. But take example of your internal applications. They can break with the new versions. Maybe because of lack of testing, or maybe because of lack of verifying certain features in the application. So using latest tag is a very bad practice. And your organization has this as a compliance requirement. Even if a developer accidentally tries to use the latest tag, the deployment should fail. How do you do this? How do you enforce policy within the cluster? This can be achieved using tools like Kyverno. So Kyverno helps you enforce policies using admission control. Now, admission control is a very big concept. In very simple words, we have complete video on admission control and even Istio as a service mesh using admission control. But because we need to know the concept at a high level at this point, let me tell you, admission control is nothing but Kubernetes allows you to perform admission control, that is for validation as well as mutation. So whenever you deploy a pod, or you deploy a config map, you deploy a service, if you create an admission controller in the Kubernetes cluster, you can validate the resources or you can mutate the resources. Validation is nothing but you can verify. Okay, if developer creates a pod in Kubernetes, using the validation admission controller, you can check if the pod, if the image field in the pod is using latest tag. If it is using, you can block the pod. You can stop creating the pod. In the same way, Kubernetes also supports mutation admission controller. If you create a mutation admission controller, every time a pod is created or every time a config map is created, maybe you can automatically add certain labels to the pod, or maybe you can add annotation to every pod that is created in the cluster. So this can be achieved using admission controllers. Once again, admission controllers are of two types. You can create validation admission controller. You can create mutation admission controller. But Abhishek, I don't know how to create these admission controllers because I don't know how to develop a controller in Kubernetes. That is where Kyverno comes into picture. Kyverno says, you don't have to learn this. Just install me on the cluster and tell me what type of admission control that you need or what type of policy that you want to enforce. Do you want to enforce the latest image tag on the cluster? No problem. Just install me. Tell me that you are looking for a validation admission controller and you are looking for blocking pods with the latest image tag. I will do it for you. And it's very simple. Let me show you the steps, how to install Kyverno and how to perform policy enforcement. Once again, these commands are in the documentation as well. First run this command, kubectl apply, followed by Kyverno install manifest. Now this will install a lot of CRDs for you. Most of these CRDs are related to admission control. Just verify the Kubernetes Kyverno is installed on your cluster. kubectl get pods -n Kyverno. Now if you notice, the pods are still in the running state. Wait for all the pods to be in the running state. Now you have to wait for this. Otherwise, when you run the next commands, you might not see the action as complete. So I'll just do -w so that I will wait for the pods to be running. There you go. It looks like the pod is initialized. In the next few seconds, we should have pod in the running state. Perfect. Now, the final step is to create the Kyverno resource. Now let's create a complete cluster policy. Okay. So this is a policy that I'm going to create. Disallow latest tag, just a random name that I provided. But what's important? Validation failure action. And this is enforce. So we are using Kubernetes for validating webhook or validating admission controller. And what does it actually validate? It is checking if any pod will be created with latest image tag. If it is created, it will fail the pod with the message image tag latest is not allowed. Let's create this first. Okay, the cluster-wide policy is created. Now let's test Kyverno. We will create a pod. Again, we will use the same payments namespace. I will create a bad pod here. kubectl run bad pod, just the name of the pod. If you see, I'm using -image nginx latest in the payments namespace. Ideally, if what we learned is right, Kyverno should block this pod. There you go. It says, hey, I will not allow the creation because what you are trying to do is image tag latest. Even before, if I do kubectl get pods -n payments, you will notice the bad pod is not even created. That means admission control is working even before your execution. It just verified if you have access to the cluster. Okay, you have access to the cluster. Then you are trying to create a pod. Kyverno came into picture or admission controller came into picture. It tried to run the validation webhook and it verified. Okay, you cannot create nginx with the latest tag. You can create nginx with v1, v2, anything. But you cannot do it with the latest tag. That's why I will block the access. And there you go. It blocked the access as well. It did not create nginx pod with the latest tag. You can try something else. Okay. So let's say you try to create nginx v1. Now this might not exist. Your image might run into not valid image or image pullback off. But at least I want to show you, in this case, Kyverno will not block your request. There you go, pod is created. Even if you try to do this action in the default namespace, even there, Kyverno will block your request because it's a cluster policy. Across the cluster, this action is blocked. This way, you should make use of Kyverno in your organization. Now, this has become very important in the recent times because companies today have lot of compliance requirements. Not only latest tech, you can say that a pod cannot be created without resource requests and limits. A pod should definitely have things like, you know, very simple things. For example, health check, liveness probe, readiness probe. So you can define anything that is mandatory in your organization and block otherwise with Kyverno. Perfect. Even I have complete video on Kyverno. If you want to verify more actions, if you want to deep dive into Kyverno, you can just go through my Kyverno deep dive video. But at least this information is enough if you are getting started with Kubernetes security. Now we learned about policies. Now let's move to a different concept, a very, very simple concept. Till now you learned about slightly complex topics like the RBAC, network policies, admission control. Now let's go to a very simple concept, that is secret management. Now we all deal with secrets on day-to-day basis. For example, we deal with passwords. We deal with API tokens. We deal with certificates. We deal with PEM files. How do you manage them on the Kubernetes cluster? Obviously, if you are using them on your virtual machine, if you are using them on your laptop, when you deploy your application to Kubernetes, you have to deal with these resources as well. How do you do that? This is where Kubernetes supports a resource called secrets resource. The same name, right? Your secrets are managed in Kubernetes using Kubernetes secrets resources. All that you have to do, if you want to store a password in Kubernetes, maybe you deployed a pod and this pod needs database password. So your backend pod wants to access the database pod, but for accessing the database part, it needs the database password. You cannot hard code that in your application. It's a very bad practice. So what you do, along with the pod, you create a secret resource. And within this secret resource, right, which is basically a manifest, within this manifest, you provide the DB username and the DB password. Now within the pod, okay, once you create the secret resource, within the pod manifest, you read this secret as environment variable. That's it. Now the pod has the DB username and DB password within its environment variable, so it can access the information. Let me show you this in action as well. So first of all, we will create a DB secret. So you will do that using kubectl create secret. Whenever I'm using secret or whenever I'm using create mybad, I can actually use a manifest as well. But to make it simple, I'm using the CLI commands. kubectl create secret, generic secret. The name of the secret is the DB secret. Hyphen literal. The username is admin. Password, let's say the password is strong password 123 or password is Abhishek123, anything. And let's create this in the payments namespace. Okay, now the secret is created. How can this secret be read by a pod in this namespace? For that, when you create the pod, let's say this pod wants to read the secret. This is in the payments namespace. All that it has to do, it has to provide the environment variable feed. So now this pod will have an environment variable called DB user. From where does it get the DB user? It gets it from the secret reference name. Secret key name of the secret is DB secret. And within the DB secret, The username is with the key username, right? And similarly, from where does it get the DB password? Get the value from a secret called DB secret, and within the DB secret, use the field called as password. But Abhishek, when I do this, will a secret resource be created and will it have fields like username and password, the ones that I provided? Yes. You can also verify if you do kubectl edit secret followed by name of the secret, DB secret -n payments, you will see this is a secret manifest, and within the secret manifest, you have username as a field, password as a field. That's why when we created the pod here, or when we are creating a pod here, we are referencing the username and password field from the DB secret. And that is using the values from secret key reference. This is the same syntax that you have to use. In any pod, in any namespace, the syntax will remain the same. You are reading the secret as an environment variable. The name of the secret is the DB secret, and within the DB secret, the username name is username and the password name is password. Perfect. Now let's see what happens. Dev namespace is not found. Okay, that's expected. I'll change the namespace here to payments. There you go. Secret is created. Now let's look into the pod. I'll just exec the pod. kubectl exec -it. Name of the pod is secret demo -n payments --sh. Now if I just do env here, you will find the username and the password. There you go. DB user is admin, and you will also find the DB password. Somewhere here, you should see the DB password. There you go. So this is the DB username. This is the DB password. Username is admin. Password is strong password 123. This is how secret should be created, and secrets should be read within the pods. I'll repeat this one more time. When you have secrets in your Kubernetes cluster, or when you want one of the pod in the cluster to get some secrets like the DB secret or API token, first step, create a secret resource in Kubernetes. When you create the secret resource, within the secret resource, provide the username, provide the password, and then create the pod. Within the pod, use environment variables. Let's say you want to use the read the username. Read that within the username environment variable. How do you do that? You will use this field called secret reference, the one that we used here. Secret key reference, name of the secret, and field name in the secret. Similarly, if you want to read the password, provide the name of the secret and password reference in the secret. That's it. But Abhishek, are secrets really secure? Because, end of the day, you are storing secrets within a file. Are these files encrypted? The answer is no. When you create secrets in Kubernetes, they are not encrypted. They are only encoded in Kubernetes. That is, they are encoded as base 64 values. Now, this is a problem. Because your secrets are base 64 encoded, anyone that has access to your namespace, they can use kubectl edit command. So if they have access to your namespace, if they have access to all the resources in your namespace, they can just run kubectl edit command and they can read the secrets, which is a problem. And even, okay, Abhishek, I'll block access to the secrets. I'll implement RBAC, right? By implementing RBAC, I will not allow anyone to perform kubectl edit on the secrets resource. That's a good move. In fact, That is very good thing that you can do. Create RBAC and block access to any secrets using kubectl edit. But still, what if you want to store secrets in Git? Which is a valid thing, right? Just like how do you store your pod definition, or how do you store your deployment manifest? How do you store your config manifest? In the same way, if you are implementing GitOps, or if you are implementing deployments through Git, how do you store secrets in Git? Now, this is a big challenge. Kubernetes does not solve this inherently. What you need to do, you need something like ESO, that is external secrets operator. But Abhishek, what exactly is the problem? I still did not get it. Why can't I store my secrets in Git repository? Now, if you take the same secret here, right? You run kubectl edit secret, you copy this and you put this in a Git repository. You think this is secure because Abhishek, nobody can understand what my password is. This is in some random string. Just copy this. Okay. Anyone from the Git repository can copy this. They can run echo followed by base 64. They'll just run this command base 64 hyphen decode, and they can see your password, strong password 123. This is what I'm talking about. Kubernetes secrets are not secure by default. They are only base 64 encoded. So if you store them in the Git, any person who knows Kubernetes, they know they're only base 64 encoded. They'll copy the value and they will run base 64 hyphen decode. How do you prevent this? So what you will do, you will install external secrets operator on your cluster. How does this work? So this works with 3 simple steps. First thing, you will install secret providers like Vault. What is Vault? Vault is a safe place. Instead of storing your secrets anywhere, you will store your secrets in the Vault. Vault can be HashiCorp Vault or any other implementation of the Vault. You will install Vault on the cluster where you will start storing your secrets. It can be your DB password, it can be your API tokens, anything. Step 2, you will add Vault as your secret store. That is, you will tell external secrets operator, hey, Vault is my secret store. All the secret values are in the Vault. And finally, you will create a manifest called external secret. What does this external secret have? It does not have the secret. It just has information of the Vault reference. That is, my secret is stored in the Vault and it is stored with a particular reference name. So in the external secret, you will only have the reference name. Nobody who checks your manifest in the Git knows what does this reference name mean. They can find the reference name. They don't know where is your Vault. They don't know what is the real username and password in the Vault. Only external secrets operator can understand this external secret manifest. It will read the reference because it knows your secret store is Vault. By reading it, it will go to Vault and it will fetch the real username and the password. And it will store those values in the Kubernetes cluster. Right? Very sophisticated approach, but 3 simple steps. First thing, install Vault, start storing your secrets within the Vault, add Vault as your secret store to ESO, and then instead of storing your username and password in the Kubernetes secret directly, what you can simply do, you will create a manifest called external secret manifest where you will have the references of your Vault. You will say, my secret is stored in a particular path of the Vault. Only external secrets operator understands it. It looks at the reference. Okay, it knows this path should be searched in the secret store that is Vault. It will search it in the Vault. and it will get the exact values and store the values in the Kubernetes cluster. So you can happily store your external secrets YAML file in the Git repository. Now let's see this in action. When you see this in action, you will understand this better. First step, I'll simply start with installing external secrets, right? Installing external secrets, we will do it using Helm. This is the repo for external secrets operator. Let's add the Helm repository. If you already have the Helm repository, in my case, I already have it. I'll just update the Helm repo. Now let's run the Helm install command to install the external secrets operator. We added the repo. Now let's run the Helm install command. There you go. The install is successful. Let's verify. kubectl get pods -n external secrets. The container is still in the creating state. Like I told you during Kyverno as well, please wait while the pods are in the container creating status. They should be in the running status. Let's recheck. There you go. So the pods are in the running status. Now the second step, let's install Vault. Installing Vault on Kubernetes is very simple. You just need this manifest. We have this manifest in our Git repository as well. Just run this manifest. What is it doing? It is creating Vault namespace, and then it is just installing the Vault 1.15 image. Usually when you try to set up Vault on a virtual machine, you might have to run set of commands, but on Kubernetes, we will just run a simple deployment manifest and then expose the Vault if you just want to access the Vault through the UI. If you don't want to access Vault through UI, you can skip this step. In my case, I'll do everything from the CLI. So I'll just stop the Vault. But this was just to show you, you can also access it from your browser and perform the steps from the browser. Cool. So we installed ESO, we installed Vault. Now the next step is to add Vault as the secret store, because we have to tell external secrets operator our secrets will be stored in the Vault. How do you do that? First, let's just exec to the Vault pod, the pod that we created. Okay, here how do you do that? Run this command kubectl apply -f. And I'm just trying to make it simple for you instead of taking the manifest from official documentation. I try to put everything in our GitHub repository because these manifests are not very important for you. You can get this from any sources, the official documentation, ChatGPT. What's important for you is to know the concept. So this is the secret store manifest. And here I'm configuring Vault as the secret store. Vault is running on port 8200. I'm just providing the location of the Vault pod. Cool. So this should add Vault as the secret store. So we are done with both of these steps. Now we will just store a secret within the Vault. Okay, because we want to read the secret from Vault in the external secrets. So first, let's store a secret in the Vault. How do you do that? We will exec to the Vault pod, or instead of this, you can even access Vault from the UI. Two things. If you are a CLI guy like me, do it from the CLI using Vault CLI command. If you want to do it from the browser, just use port forward and access the Vault through the UI. Now you just need to export the Vault IP address and provide the Vault token as root. This is for connecting to the Vault instance. Now using this command, that is Vault KV, we are creating a key value pair in the Vault. Put secret called DB secret. The location of the secrets is secret slash payment slash DB. This is within the vault. This is a folder, and this is another folder where you are storing a key value pair called key is username and value is the password. Where the username, sorry, key is username, value is admin, key is password, and value is super secret 123. Basically, we are storing two key value pairs. This is one key value pair. Username is the key, password, value is the admin, my bad. Username is the password, sorry, key is the password, and value is secret superstar 123. Sorry for the confusion. This is the key, this is the value. This is the key, this is the value. We are creating two key value pairs here. Okay, now both the key value pairs are stored. Finally, let's try to create an external secret. How do we do that? Again, it's just a manifest. In Kubernetes, whatever you do, you only use the manifests. kubectl apply -f followed by external secrets manifest. One more time, why are we using this external secrets manifest? Because you cannot directly store secrets in Git. Now you can take this external secret and store it anywhere you want. Even if someone asks you, hey, I want to just know the DB username and password, I am the right person. Tell them, take this external secret. If you are the right person, deploy this on your Kubernetes cluster. We already installed external secrets on the cluster. It will take the username and password and it will create secret on the cluster. It will figure out. You don't need to get the username and the password. And as we learned in the external secrets, what are we doing? We are saying secret store reference is the vault. And within the vault, there is username within payments DB folder. There is password within the payments DB folder or the path. This is the path for the username and this is the path for the password. Where? Within vault secret store. Cool. Let's also install this. Now let's verify. I haven't created any secret, right? Now if I do kubectl, right? kubectl get secret -n payments, you will see there is a DB secret. And what is the value of this DB secret? Let's verify that. kubectl edit DB secret or secret slash DB secret -n payments. There you go. So our username for the DB secret is provided and even password for the DB secret is provided. You don't have to do anything. External secrets will create this secret for you. Even if you try to delete this secret, again, external secrets will create the secret for you. Now in the pod, instead of mentioning directly the username and password, you can even provide a reference of this external secret. So this is how secret management is performed in real time. A lot of people stop their learning at the secrets, which is also good. In Kubernetes, secrets can also help you store the sensitive data if you're using it with a strong RBAC. Even after using the strong RBAC, if you need to store your secret in a Git repository, what you need is external secrets operator. Perfect. So this is how good DevSecOps engineers secure their Kubernetes cluster. We learned about 6 practices in the video. We started with understanding namespaces. Then we learned about RBAC. Then we learned about network policies. Then we learned about Kyverno, dynamic admission control. We learned about secrets and external secrets operator. I hope you found today's video informative. If you have any specific questions, do let me know in the comment section. Also, there are complete implementation videos for most of these concepts. If you want to learn, go to our Kubernetes playlist. If you go to the channel, you will find multiple playlists. Go to the Kubernetes playlist. You will find most of the Kubernetes concepts there. See you all in the next video. Take care.